Okay, great. Thank you. Welcome, everybody. This is Kubernetes SIG API Machinery bi-weekly meeting. Today is March 8th of 2023. And we have a couple of really nice topics that I'm happy to introduce and give the control to Daniel to kick it off.
Hi. So this first one, we started to have a discussion in Slack and it got pretty big, so we thought we would have a live one. I'll summarize the concern. So when you start an upgrade and if you have the sort of upgrade where you are upgrading a whole system at a time, you'll have some API servers in your system at a certain version and some API servers at the prior version. And in that case, the API server that has come up most recently has written to etcd the list of API services that it knows about, and it makes an API service for every built-in type. So this means that there's types in etcd corresponding to the set of built-ins that the most recently started API server knows about, which may have built-ins that other API servers don't know about. However, all API servers serve the discovery information directly out of this data in etcd, which means that when you go to discovery, you may see types like no matter which you see the same set of types, no matter which API server you get discovery from, but depending on which API server you actually connect to, some of those types may not actually exist.
Question on that.
Yeah.
I would expect that a server that is informed that a new group exists would show the new version for that group, but I don't think it would know the types that were contained in that new group version. So for instance, when we introduce auto-scaling v2, I wouldn't expect an old API server to be able to tell me that a horizontal pod autoscaler was in that group.
Yeah, I was going to say it's actually worse than what Daniel said, where only the group version information is registered.
Right.
A list of resources.
Yeah, not the it doesn't know the kinds. You'll get an error if you continue the discovery thread. You can't complete discovery because you just get an error.
Yeah. Fede, if you want to pull up the second link, the doc, that might be. I tried to make a table. I do love making tables.
So I have two different ideas that could solve this. I'll solve it partially or completely, but we can go ahead and discuss it more before I propose harebrained schemes.
And for those who are curious, I dropped links to where those behaviors happen, just in case you want to prove to yourself like this is actually what happens. So I think the first scenario is the one that James was hitting, where
yeah, I didn't describe the actual problem. Like the problem report is like the namespace lifecycle controller is doing a ton of lists, which
yeah. So I think either way we solve this, if you have discovery on one server advertising something that it doesn't know how to actually serve, you run into one set of problems. If you have local servers avoid publishing discovery information for things which other servers are actually serving, you run into a separate set of problems, which in some ways are maybe worse. It's hard to judge. So
okay,
yeah.
Well, you may have signed up for the complicated of the two solutions that I was going to propose.
If you scroll down, basically the old server says, hey, like there's a group version that exists. I'm told it exists. If you try to get details about it, I'll give you a 404 because I don't know about it. And if you try to make API calls to it, I'll give you a 404 because I don't know about it. Like,
which should
that
probably
at
be
least
a 503.
tells, maybe, yeah, maybe.
404 discovery, 503 on, yeah.
Yeah, I could buy a 503 from Kube Aggregator if the local routing to something an API service exists for hits it at end. I could buy that. like at least that gives discovery driven controllers like a hint that there is an API. Like it tells them that your knowledge is incomplete. Like some controllers react badly to that. Some controllers, that actually puts them into like a safe mode where they're saying, my job is to clean up. And if I don't have complete information, then I can't be sure I cleaned up. So I'm gonna like, I guess, fail safe. And so anyway, that the current behavior is the top left corner of this table, which is old server publishes existence of the version but if a controller is talking to that server, like it fails to get to complete discovery and hangs, sort of.
Okay. And you've conveniently left a blank box, the impossible box blank.
I wasn't sure what to think about a server advertising discovery, something that no server was actually serving. That seemed weird. I wasn't sure why we would do that.
Sorry, I misread the columns,
Yeah.
or the rows.
Anyway.
Okay, I'll propose two different ways that we could possibly solve this problem. And the first one is we can make it work the way I thought it worked, which it doesn't work, which is the aggregator reads the set of built-ins, reads all the API services from etcd, ignores all those with a null backend, also gets the list from its local, it merges this with the list that it gets from its local API server. Right, we modify the controller that's currently writing these things, we make that available to the aggregator. So it merges those two things and uses that for serving discovery rather than directly using etcd. Then you have the case, then it would be the case that API server advertises all and only the built-ins that it can serve locally. So that is probably not too bad.
Doesn't that move us to the top right corner of this table?
Yes, it gives us the other set of problems.
But it's red, Daniel. It's red text. We don't want red text.
Okay, so that's the way I thought it worked. And I thought that you could avoid the problem by doing that and then keeping controllers connected only to their local API server and not going through a load balancer.
I think that leaves us in a worse spot because it makes it possible for someone who has spoken to the other API server to have produced one of these resources, and then the namespace lifecycle controller will not clean it up and will not wait.
Yeah.
Yeah. Okay. That could certainly be a problem. Okay. So my second idea is we extend. This is going to rely on the API server identity effort. We extend the API services field. So right now it's got like if the backend is null, then you know it's a built-in. So we extend it and add a list of alternates. And an API server that knows how to serve a certain built-in puts itself in this list of alternates, right? And a API server that is attempting to serve a resource that it doesn't host looks at the list of alternates and proxies the request over to the API server that can serve it. I think it's, and then it's more complicated because we have to match up the alternates with API server identity and remove ones that don't exist anymore.
Do API servers have network visibility to each other?
Yeah.
Yeah, and it's annoying because API server has to put in an IP address that is accessible to other API servers, and that may not necessarily be accessible to end users who can see this. So
what about an alternative that uses the API storage API, the storage version? That one has a list of resources because we create one per resource. It has a list of API servers because it has a status section for each API server based on their identity. And given that information, we should be able, it doesn't today, I think, contain, it might today contain serializations. but it would give us a spot to say, this is enough to actually build discovery out of this resource that we have.
You could get the same thing by storing discovery document in etcd somewhere, right?
I mean, we could, but I'm trying to remember what the schema of the storage version API is, whether it already contains enough information to know what to expose in discovery. I think it's close.
So that kind of thinking can fix discovery, so everybody will discover the same. But if you're connected to the wrong API server, you still can't successfully list the objects, right?
True. Could we expand it and say, nah, I mean, it would be a different resource, but could you expand it and then start voting on whether we should serve? I think it's what we've wanted, and it would give us a watchable.
Yeah, that's another. That ties into the feature thing. That would be easy with the feature thing that I'm working on a proposal for. But yeah, that's another solution. Is if each API server knew what other API servers could serve, and then they exposed the set of resources that all API servers were able to serve.
So that, I think, moves you to the bottom right of that table. And I was trying to figure out like what the implications of that would be if during an upgrade, the new API versions aren't available yet because there are still old servers in the cluster. Then any client we write has to be able to deal with absence of those versions and I guess still write to the previous version. That gets really awkward around like the beta to GA transition where we're like, all right, it actually, an API reached GA. We would really like to make our controller that we release with this version use the GA API. In fact, if it's a new API, the beta API may not even be enabled. But my controller might not become healthy until the old servers are gone. I was having trouble thinking about
isn't the order of upgrade that we upgrade the QAPI server first in all the cases, and that's why you're able to rely on it today?
That's what we document. That's not what we do in practice, but yeah.
But today, like the way the system works today, if controllers only talk to their local API server, then they can use the versions released in their release and they're available and it sort of works the way you would expect. The cross server stuff and a client that talks through a load balancer to arbitrary servers runs into problems. But a lot of deployments, version match controllers and API server and deploy them so the controllers are talking locally to their server. That works decently well.
I mean, they already have to have checks enabled to verify readiness and health. I mean, in the end, what's one more check there? And that check that check's not stock, right? Like you think about the flow that you have to have today in order to contact the local QAPI server and have it be correct. There needs to be a constant check to be sure that the server you're talking to is healthy and ready.
Right.
It doesn't seem notably harder.
If we make it so that a server no longer serves the built-ins that it knows about, conditional on older servers rotating out of the cluster, that complicates the controllers that we write that run against local API servers, where today they were pretty simple.
It sounds like the deployments that do that need to be sure that the server they're contacting, in addition to now they already have to check readiness and then have to have a way to kill their controllers when they become not ready. They also have to have an additional check, are you serving? I mean, that doesn't seem entirely unreasonable. It's an unusual deployment. How do you run a readiness check?
Why do you think they need to do readiness checks on their local API server?
Because if the local API server restarts, it will serve a discovery document before it is ready that does not include CRDs. So if you hit a QAPI server that is not ready,
No, a lot of work was done to make sure that we serve 503s for CRDs that haven't loaded yet. And there
No, I
seems
mean,
to be a
like you
bug
don't
with
even
that,
know
but
that you haven't loaded them yet. Like you,
So assuming a controller talks to its local server, waits for it to be ready, and then talks to it, if that server, even once ready, is not serving new APIs and will at some later point dynamically, that's just really different from today's behavior and seems harder to write a controller against to me.
different, but I think you're already facing issues today. I mean, you might not hit them very often, but like we hit those, which is why we decided to stop doing that.
Stop doing what?
Hitting a local API server, because when they restart, they don't up until about 2 releases ago, they didn't serve 503s, they served 404s. And so you get discovery that was incomplete, had 404s, and you would break garbage collection.
it should be very transient though, right?
Well,
Well, it shouldn't be
varies
serving
relative.
It shouldn't be serving 404s. That's a bug.
I think we eventually addressed it. I don't remember. I think before we go,
Yeah,
ready,
I looked at it a
now
little
serves
bit,
a
and
503.
there's a report that it doesn't work in all cases, and but it wasn't obvious how it's broken. I looked into it a little bit and didn't have time to look more. Jordan knows what I'm
Yeah.
talking about because he tagged me in it.
Yeah.
Um,
I'm mostly trying to understand what our controller would look like if we simultaneously needed a controller on the new version to be able to like run and be healthy, so that an old server and controller could rotate out of the cluster, but the new controller could not assume the GA API was available, and it could not assume the beta API was available. Like, are we doomed to write every controller able to speak multiple versions now?
Yeah, no, we shouldn't paint ourselves into that corner. I'm still hung up on this, like, you need to know if API server is ready, because there's no way to like know that it's ready. It could restart at any time, or it could go unhealthy for who knows why.
Yeah, I mean, that's why using localhost is risky.
Yeah, because of an outage. You could have an outage and it doesn't fail over to one of the other API servers. Is that what you're saying?
If you have a controller contacting localhost that doesn't essentially reproduce its own readiness checking load balancer, you end up in a case where you can contact something that isn't ready,
so
and the results are undefined.
I mean, I think you can always end up like, even if you're behind a load balancer, you could end up talking to an API server that then goes unhealthy, or is unhealthy between readiness checks for some reason. So like, it has to be safe to talk to an unready
always
API
be
server.
past the post, right? Once you reach a point where you have synchronized at least once, you are in a significantly better spot than I have never synchronized before.
Yeah, so checking readiness on startup makes sense.
I think
the kube controller manager doesn't get restarted when the API server goes down. So those two aren't tightly coupled.
Why is that? You're scaring me. Why do we require controller manager to restart when API server restarts?
Because that's when the health check is. The health check was added to try to bypass this problem, but it doesn't actually address the problem when the API server restarts independently. Maybe it panicked and restarts. Or
the solution to that doesn't seem to be to make everything go through a load balancer, which then still has the same problem.
Yeah,
it seems to be to make the server 503 on APIs before it's ready.
It has to be safe to talk to a unready API server, because you can't avoid it. You can't avoid it. It has to be safe. And maybe that means API server holds requests until it's safe to proceed. Or
we can try to search the agenda for the last time this came up. I would be interesting to compare past opinions to current opinions in that sort of scenario. I can hear the concern.
Yeah, I make no claims that I haven't changed my mind without realizing it.
I also think that it's easier to not have a load balancer built into every client to try to figure out, is it safe to talk to this one? Trying to make it safe to talk to an unready QAPI server, noble goal. Holding.
I just don't see how it could work any other way. You're going to talk to unready API servers at some point.
You can make it extremely unlikely that that happens to you. In terms of overlap between V1 and V1 beta 1, I thought that we made it the case that you had to have one release of overlap where you had both, and that we said if you didn't have that, we would require you to do another beta.
I'm talking about serving. Like, you're not required, clusters are not required to serve the beta.
That's true. Okay.
So yeah, storage version is going to stay beta because you might have been serving it previously. I'm not talking about the internal storage version stuff. I'm talking about actually what is our now default progression, which is, new API shows up, hits alpha, hits beta, not served by default. Hopefully people are trying it, giving feedback. But if they don't, then it goes to GA, and now we're going to cut a release where the API went to GA. What version do we make the controller speak? Today, we say a controller can assume that it's talking to an API server, at least as new as it, that is able to serve the API versions that controller knows about.
So I think the deal is, if you've got a new controller that only understands the new version and an old controller that only understands the old version, the new controller needs to wait until the new version appears. And until then, it can be either uncontrolled or the old controller can control it, depending on who has the lock. And yeah, you're going to have it, you're potentially taking an outage over an upgrade. If we had locks independently taken by controllers instead of one global one, then we wouldn't have this problem. Jordan loves this idea from his, judging from the expression.
I'm just like, I know it seems reasonable to say, like, I'm going to bring in a new control plane member, and so I have a new server, and I have a new controller manager, and I want to make sure they're both happy and healthy before I cut the old member out of the cluster.
But even if you do that, and you're turning the GA version on for the first time, and there is no beta, it doesn't have anything to control anyway until the version starts serving, right?
If the beta was not enabled. Ugh. I'm just imagining the updates to the SKU upgrade document, which today, from a controller perspective, is actually decently straightforward. And with this, I'm not sure what I would even tell people to do.
Okay, so rounding up our options, what do people think of the option of letting API servers proxy traffic to an API server that can serve it?
It's creative.
Do we know how typical it is for API servers to have network visibility to each other?
We know they have network visibility to etcd, and etcd members have network visibility to each other. Yeah, if they can't talk to each other, then you're in a not worse state than you are today, at least.
How would API server know that other API servers can serve this request?
Yeah, so the mechanism I proposed at the beginning of the meeting is they write themselves as alternates in, we add an alternates field to the API service object, and they write themselves in there. There's like basically we would be inventing some way. And I think basically the only hard part is to remove API servers that are old or gone or missing, and we'll be able to do that because of the API server identity effort. This is like one of the things that I've been excited to use the API server identity for.
I think it could work. I'm not as convinced that access to etcd potentially via a proxy is
no, I didn't mean like that yeah, sorry, I didn't mean that guarantees that the network is open for you already. It's a possibility proof, but not a it doesn't mean that people wouldn't have to make networking changes to use this.
Maybe to clarify something you mentioned earlier. So the use case when the controller talks locally to API server in the context of upgrade, that can exist between two controllers in different versions only in a transient period of time, right? It's at some point all controllers should go out of scope.
Yes, though transient it could be hours or days. I mean,
right.
Yeah.
In that sense, that essentially if the client hits, or whatever controller picks the reconciliation, they may produce inconsistent behavior because you have two different controllers operating two different versions, right?
Yeah.
So the most noteworthy failure there would be a new controller starts up, new resources are created on a new server. The controller there loses its lease. A controller starts on an old server. It contacts its local API server. It gets a view of discovery today that doesn't include the new resource and fails to clean up.
Or will it fail, or will it just simply ignore the new resource?
It would ignore the new resources that had been created.
It fails to do discovery today because
it depends. So we're looking at
depends on which API server most recently booted.
If you scroll down to scenario 2, there's actually a worse case which already exists today, where we add a new resource to an existing group version. And so in this case, server A and server B both know about the group version, both are happy serving discovery for it, but server B, the new server, has a new resource. And so clients talking to the new server is like, oh, I've got this brand new resource. I'm going to go create some of those. Namespace controller running against the old server says, I need to clean up a namespace. Let me see what's in this group version. Okay, I've got my list of old resources. I successfully cleaned them up. Namespace deleted. So this exists today.
I think we saw that back when we were using localhost, because the RPL start would always prefer the old kube controller manager for cleanup, which always got the old list.
Yeah.
And we faced issues. I did provide dates for when those meetings were, August 25 and November, whenever, if you want to go back. I think in the end, we did make a 503 for a fall through case until you were ready.
That sounds like the PR that I looked at. Yeah.
Yeah, but that is different than it's okay to switch between old and new. It really seems like you want to get your QAPI servers updated first. And
yeah, I agree with you. I have always recommended that ordering.
Wait. Not your Kube API servers updated first. Your APIs. Oh, you just said API server. I'm sorry. I'm losing my mind. Today is Friday, right?
Yeah.
Yeah. API servers first.
Yeah.
There is also an old design for how you could try to change it. There were problems.
But in practice, I don't think very many installations do update API servers first. Actually, you should update webhooks first, then API servers, then controllers.
Yeah. Well, I can't speak to all of them. I know some do.
Does kubeadm set up clusters? I don't even think kubeadm sets up clusters with that upgrade order.
No, it's control plane hosts which bundle all the components of a piece.
yeah, we figured that out too late for the majority of installations to act on that. Okay, so if I produced a KEP or an issue proposing this, people would not reject it out of hand, proxying between API servers.
Trying to automatically set up that trust could be interesting. So today, the trust of a front proxy is something you only have to do for aggregated APIs. I suspect most do because the way metric server came in, they probably have that capability.
I mean, all API servers should have a serving cert served signed by a CA that they trust, right?
Serving cert, yes.
So is there a reason not to use that? Do we need to make people get a new cert, or is there a reason not to use that cert?
There's no guarantee that it has a client usage. Right, so for a front proxy, you have to be able to verify the identity of the server that is telling you it's okay, this is a cluster admin.
I mean, you know, actually, since we have the etcd backend, worst case, we can have servers generate a cert on startup and put the public key in their identity thing, and right, so that people don't have to configure that, and you get a different cert every startup. So I'm just thinking about lowering
the. Have to consider how to do it. I'm not saying it can't.
Okay.
Done.
Yeah. No, I agree. We don't want to get that wrong. Yeah. My concern is just not making installations cough up another cert for us, because I think that would hamper people's enthusiasm.
Yeah, I think there's a few pieces we can carve out and improve along the way to that. So making sure that we're actually getting 503s when we think we should be getting 503s is a thing that it sounds like maybe was already done, but maybe it has some gaps. So closing those gaps seems like a good.
Yeah.
The gap that I talked about in the second scenario where a new resource shows up, even if we want a server to be able to proxy resources, requests for resources it doesn't have to other servers who do have those, in order to do that, it's going to need to know that those resources exist. So figuring out how to record the existence of those resources and which servers know about them, like that's a useful intermediate step, even if the only thing we did with it was build out discovery one more layer. At least then it would help discovery clients like get one more successful step, and then maybe they would need to like go make calls to those and they would still fail until we got the proxying things set up. But like better, more complete information seems like only a positive thing.
Yeah.
Recording.
I'd be very happy to see an API that tried to provide a resource that indicates these are the resources that exist. I think that would be useful for a lot of reasons.
Maybe we can also qualify them somehow that they exist as a part of the upgrade. In other words, they only may exist in some API servers, and the other resources universally exist in all API servers.
That's similar to what the storage version API does. It has in its status, it has I think a slice that lists an API server ID, says, I recognize this one, and it says, I encode it here. It would have to be slightly different for something like this, but I think a similar mechanism to use.
And then just selfishly, like the two controllers that we have that are driven off of discovery and watch everything, so garbage collection and namespace, like if we can improve those to not fail so catastrophically, that would be nice. And probably something we could do like in one release instead of multiple as we're waiting for a better solution, proxying or otherwise. I don't know. I was surprised the namespace controller like was spamming so badly. I would have expected if it had 100 namespaces to clean up and they all got deleted 10 minutes ago, like it should be able to coalesce those into saying like I need discovery that's at least successful within the last 10 minutes. Like it shouldn't be repeating all of that every time. So I think there's just tactical things we can do to improve our two discovery controllers.
There was an API behavior that I was interested in. Trying to list out all objects of a certain type in a given namespace using a URL path of APIs, something, group version, namespace foo, / my resource. Pretty clear that would 404 and probably should. A request that came in for APIs group version namespace, and then instead of namespace said my resource, which would normally list all of them. And then it passes a query parameter that says I want them confined to namespace equals foo. Is it reasonable for such a request to return an empty list instead of a 404?
What do you mean, the 404 because the namespace doesn't exist or because the resource type doesn't exist?
Because the namespace doesn't exist.
That doesn't 404 today.
It doesn't 404 today?
No.
If I translate what you're saying if you ask to list the objects and use the path to a namespace, you get some answer. And if you ask to list all objects, but with a selector that mentions the namespace, potentially you get a different answer.
Yeah, I'm wondering both what it does today. I would expect the first one there to 404 if the namespace doesn't exist. And this one, I'm undecided on the second one. And what I'm hearing from you, Jordan, is that the first one doesn't 404?
Well, I believe the code turns one of those into the other.
I think both of those return an empty list.
Yeah, I think that's probably what
I
it does.
wish I had
today.
a cluster to figure that out on. That's interesting that it would return an empty list. Okay. So that makes the case distinguishable. So that's nice.
You mean
if the type is known and
I
there
see
are
what you're
no
saying.
instances of that type, you get back an empty list. If the type is unknown, I thought you got back a 404 today.
I think you do after you are ready. I think before you're ready, I believe the fall through is a 503.
Yeah. When you start talking about individual instances, that's what gets really interesting and can really trip up the garbage collector. So if the garbage collector, before it deletes an object, looks at to make sure all parents are absent. And so it's going to make requests for individual parent items. And those will return a 404 if the object doesn't exist, or I think if the type is unknown to the server. And that's
there should actually be there should be three cases there. 404 if the type is known and it doesn't exist and the object doesn't exist. It should be 404 if the type is known not to exist. It should be 503 if the type is known but doesn't exist locally.
I need you to write that in the notes.
There's the PR that changed at least part of it, and I don't know if it got, I think it got the fall through at the very end of the handler chain, but it has been.
Yeah, that is the PR that I was looking at, and it is not so easy to understand what is going on in this PR. All right, should we wrap up this conversation item? I'm not sure if we decided anything.
Let's fill out in the notes like what this individual things we want to verify and or fix are, and then we can start like putting names to them and saying who's going to verify this, or file an issue with details of what we want to fix. And the bigger and more complex fixes, like, stuff with API implications, record existence of resources and proxy between API servers, will need keps. I think some of the earlier ones can probably just be issues or bug fixes.
Okay.
And might want to find a way to describe what's at risk for controllers controllers that don't exist in a spot where they can be sure that the API server has been upgraded.
Yeah, we should document the problems that people are at risk for.
You said there were 3 cases, and I can only think of 2, Daniel. If the type is known and the object is absent, you get a 404. If the type is unknown, you get, I don't know what you get. I think you still get a 404.
Yeah, I'm saying there should be 2 cases there, but today there's only 1. It's like API server doesn't have the type, you get a 404. But it should, if the type is present in discovery, but not in the local API server, that should 503, right? Like I can't serve this, but some other API server could. We shouldn't give a 404 for that. That's lying.
That would require information.
Yeah, that requires some extra information that is absolutely not present. Yeah, totally agree. All right. On this list next, yeah, I thought if we had time left, we would do stuff from the backlog, and looks like we've already got one from the backlog that's been moved down. Is this the same as the question in Slack a few days ago about
yes,
maybe there was a proposal is like put a like a field or annotation or something in on objects so the object can select which controller controls it.
Exactly. So yeah, I think that's generally or broadly to describe this question is that today essentially very hard to extend built-in controllers. And if depends on the object, sometimes it's not easy to even reproduce the behavior with your own object. Let's say you create your own type, because how deeply some built-in types can be entrenched across multiple surfaces. And I made an example with pod disruption budget. If I would like to experiment alternative calculations of pod disruption available disruptions field, I would have to not only implement my own pod disruption type, but also implement my own scheduler and my own eviction API, because how deeply that type is embedded into those.
Yeah. For that particular type, there's just basically no way to do it. You can't modify stuff that's inside API server, which is
understood. But I think that's what I was proposing is that trying to entertain the value in it. So in the past, we had this issue where, let's say, we could have multiple ingress controllers, which were driven by initially annotation and then by the ingress class. And even on the pod level, we do have an analog of scheduler name, where you can actually plug in different scheduler, which will schedule this pod with different behavior. So you can see that how, let's say, I could imagine that if I would implement my own PDB, let's say, disruption controller, which does not change the behavior how PDB handled by eviction API or scheduler, but it changes how the available disruptions get calculated. Then I could potentially calculate slightly differently for PDBs, which I care about or experimenting with. That notion can be applied across the board for all Kubernetes built-in types/controllers, where you want to experiment in. It could be in the path of proposing as a cap to update existing types, or it could be purely experimentations and, hey, I want to do something, playing it, and just maybe provide an orthogonal solution. Today, the only meaningful way to do it with the scheduler specifically, with the disruption controller, is to disable it in controller manager and run your own, which again, not very comfortable path for multiple reasons, because again, I will have to maintain full fork parity between functionality of the upstream disruption controller and myself, my controller. And then also I cannot do that in the environments like third-party cloud or so forth, where I don't have access to control plane. So I was thinking, first of all, what is the guidance? How to even approach that? Is it disabling controller is the reasonable path forward? Or maybe we can do something in line of maybe annotating or even exposing the metadata field saying, hey, here's this, let's say, controller name. And if it's blank, use default built-in controller. Otherwise, you can provide your own.
I've got to be honest, I'm not very bullish on this. I think,
yeah, I don't understand, especially with discussion previously.
I think, so to begin with, I think this is the wrong SIG for this. Like you're actually proposing a project-wide guidance for controllers and types. So SIG architecture is the place to go, but I see this as being pretty disruptive and very dangerous for like existing objects and making sure that the defaulting works correctly so that there's no disruption if you add something like this in. I don't have any problem at all with individual controllers opting into this. I think it's just hard to make a general mechanism for this, like because every object is controlled by some controller with a different, like, how do you identify a controller? We don't have a standard way currently.
In my example, would be probably more better way to approach the, let's say, SIG apps and say, hey, PDB folks, would you be able to tolerate annotation-based controller selection, or something? How would that kind of?
You could ask them. Like if you persuade enough, well, I would like if you get support for this, maybe you could have a field inside the object, right? Like that would be like not in metadata but inside spec.
I see.
Something like that. Like that's where that's how pods select their scheduler.
Right.
But yeah, like doing it generally for all controllers seems that makes me pretty nervous. I don't know.
No, I totally understand. I agree. It's a large surface area to add and implement, even if just for as simple as just you ignore the field and make it default for everything. Just to be able to change.
Yeah, personally, I want to do something even more invasive if I ever have a block of an enormous block of time, which is I think it would be great to have. And so okay, here's the other problem with this, which is most extensions that people want to make to existing controllers involve a schema change to the object, right? And so like just selecting a controller isn't sufficient to solve the general form of this problem. Like usually people want to add some sort of field, right? To add, I don't know, something that they want to then can also write a controller to configure. You're actually the first time I've encountered someone who wants to make a controller behavior change without a course. Like usually people want to add a field and then make the controller adapt and respect the field. And so to solve that problem, there's an idea floating around that we haven't actually seriously proposed anywhere, which is to make overlay type like a CRD, but describing fields to be inserted into an existing built-in schema. And like we're going to get to that approximately never, but it's it's something that has been considered.
I agree. If there's a change required for the type, then it's a little bit different ball game. I can also see other use cases which could involve not necessarily changing type, but changing fields. Like for example, I mean, spitballing, if I would like to introduce different taint key support. Again, I don't change in schema, but I'm changing the behavior and the value. So I would like to maybe play with that alternative controller for taint controller.
Yeah. So, yeah. No, I get why you would want to do this. I'm just not sure. Like,
yeah, and the difficulty part is that today is really no practical way to do it unless I'm willing to disable the controller and provide my own, which is not always possible. And as I mentioned, has its own challenges.
So there is another option, which is you could fight with the default controller. Right? Like if you want to do something that's not incompatible with the default controller, you can just go ahead and modify the object anyway. And some controller, like if it's the case that the built-in controller will resist your change and write it back, then you can't really do that. But maybe cases like if adding a condition is probably fine. There may be cases where it's okay to just go ahead and do something extra.
Yeah. Okay. So would you still recommend
I'm laughing at Penny's,
with the SIG architecture? Or you just
if you have one particular controller that you want to make this work with, then I would go talk to the people who own that controller. If you feel strongly about making every controller do it in a consistent way, which has has some appeal, then SIG architecture and the API review probably subgroup is the place I would go.
Okay.
Yeah, I think even the single one that you're talking about is likely to be a challenge, right? And I suspect, like, saying, like, if I'm sitting there in SIG Arch, what would I say? I would probably say something like, how about we try to demonstrate that this works with one thing before we try to make a rule about how this should work for all things. And eviction or PDBs are interesting because of how they interface with the eviction API endpoint. And as I recall, there was significant logic in there as well.
There is. In terms of demonstrating, I think we already kind of have examples today, as I mentioned earlier, ingress controllers, like where the cases where you can have multiple ingress controllers processing the same type request or ingress. So it's kind of not unprecedented in a sense. With the PDB specifically, I think it's less of a logic of changing type, it's rather than computing the status value of it, how many available disruptions you can provide or you can tolerate or whatever it is. So again, it's fully expected to work with the eviction API or schedule preemption just as it works today. So, okay.
Yeah, it is what it is.
No, and it's fully expected. I really appreciate the time and kind of the discussion.
Cool. Okay. Yeah, I think we should probably save the next two items for next time.
Yeah, sounds great. Thank you for the great discussion. Thank you, Jordan, for preparing the document with the scenarios. And thank you, everybody, for participating. I will upload the recording later today and link it to the document. And we'll hopefully see you next time in 2 weeks. Good luck with the code freeze next week.
Bye.
Bye-bye.